So, number one, we have to make the chart. So we want to start with our values of -2, -1, 0, 1, and 2. And then let's see what happens when we start plugging these in. We might have to add to the values, we might not. We're looking for the big jump of numbers and then the small clump of numbers. So you guys, I'm telling you, practice plugging this in now. On your calculator, you're going to do 1 divided by 5 in parentheses. To the -2nd, hit enter. I like to do it in multiple steps. If you want to plug it all in one, that's fine. Add 2. When I plug in a 1, or sorry, when I'm plugging in a -2, I'm getting out a 27. I'm not going to cross this out yet, but chances are I'm not graphing that. So let's plug in a -1. 1/5 to the -1st, enter, plus 2. When I plug in a -1, I get out a 7. That would be something reasonable to graph. When I plug in a 0, 1/5 to the 0 power would be 1. Add a 2, you're going to get out a 3. 1/5 to the, to the first plus 2 is 2.2. And then we're going to plug in a 2. 1/5 to the second plus 2 is 2.04. So this is actually pretty nice because we're not going to graph this. It's going to be way too far off the graph, so we won't use it. Your big jump in numbers has to be within 3, a difference of 3, so that works out right here. This is the big jump. And then the small clump has to be within 0.3. So between 3 and 2.2, that's still 0.8. That's not enough. Or I should say that's too much. So this is the small. So if we graph just even our 4 numbers there, we should be good to go. Okay? So -1, 7 is to the left 1, up 7. Zero is not going left or right, but then up 3. Over 1, up 2.2, so just barely above, right? 2, and then even smaller. Again, it's a lot of just estimating because you're now going over 2, up 2.04. So this is just, again, like you just estimate it barely above that line, which this is telling you where the asymptote line is, dashed across here. Hopefully this is what you found. Y is equal to 2. We're getting super, super close to that, but we are not going to hit it. So do your best to sketch the graph. Then we can add in our range and our domain. So domain across the board, you guys, what's it going to be? All real numbers. Yep, so all real numbers. There's the symbol for real numbers. Range is based on that asymptote line and looking at your graph. So is our graph above 2? Above y equals 2? Yes, so our y's are bigger than that. So range is y is greater than 2. Questions over this first type of problem? We just had it on the quiz. You have to do a chart for that. What'd you say? Oh, where's that at? Oh, it's in the, okay, so is this going to be growth or decay? Decay. Yep, because as you read it left to right, it's getting smaller. Decay. Or if you look at the number here, 1/5, that is greater than 0 but less than 1. So it's going to be decay. Okay. Questions on that? All right, let's go to the...
Do we have to put decay?
What'd you say?
Do we have to put decay?
If on the actual test, it'd be like the quiz where you have to circle it. Okay. Number 2 is a problem with E in it. You do not have to make a chart. You can plug it into your calculator, so I'd highly recommend grabbing your calculator. Try plugging it in right now. You're going to have to hit y equals first, then plug in. You don't need the dot between the 6 and the E. That's just representing multiplication. So 6, second button, ln is your E, to the x. So... there's 2 ways you can do the x. You can either use this little variable button where you have an x, a t, a theta, and an n, or you can do what we've been doing and do green STO. 6ex arrow over minus 6. and then graph it.
Oh, this one.
So everyone should have at least a picture of what it's looking like. I like to, as I mentioned before, I like to look at the table briefly. You don't have to do that, but I like to hit second and then graph again. It brings up the table because I do like to see when x is 0, what is the y? And you probably can tell from your graph, but when x is 0, y is 0. So I know I have a point here. And then I notice I want to look and say, okay, I'm getting super, super close to what line, but I'm not hitting it. And that's y equals -6. So this is the line we're getting really close to. And you can probably just notice that on your graph, or you could look at the table. This is your asymptote line, y equals -6. And so then after that, and again, you don't even have to plot that point that I plotted. You can really just sketch it from the graph. We're fine with that. So it just looks kind of like this. It's not perfect, but close enough, okay? And then you use what we've been doing with the domain. Domain is not changing. You really potentially could plug anything in for that x right there. So domain is all real. We haven't done any problems where it was anything different than all real numbers. Range is based off of your asymptote line right here. And where your graph is relative to that line. Is it above it or below it? So what do you guys think, above or below? Just look at the graph. Greater than? So its y's will be greater than -6. Is this growth or decay? Growth or decay?
Growth.
Growth. As you read it left to right, the graph is increasing. So this is growth. Another way for the E graphs to figure out growth or decay is you look at your exponent right here. And it was just a positive x. So that's how we know when it's positive, it's growth. When it's negative, it's decay. All right. Questions over the graphing problems. 2 just like this on the test. All right. Let's go to simplifying the expressions with exponents. There were a couple, it's a little bit of a struggle I noticed on the quiz on these ones. So let's go over these rules here. On a problem like number 3, you think of it a little bit like distributing. The 3 goes to both parts. But when you give it to the 2, it's 2 to the 3rd. And then when you give the 3 to the E with the already 3x, it's multiplied to it, like that. So now you'd plug in 2 to the 3rd into your calculator, and you get out 8. And then when you have the E to the 3 times x times 3, you'd multiply your 3 and your 3 to get 9. So this is e to the 9x. You don't have to do anything else with that. There's no negatives or anything like that. So that's your final answer. 8e to the 9x. Questions? All right, number 4. Number 4, you want to first look at your numbers out front. 4 over 8, what does that reduce to? What fraction? Or you could tell me it in the decimal form too. 0.5. Okay, so it's 0.5. 0.5 as a fraction is what? 1/2. Okay, so this is 1/2. We reduce the 4 over 8 to 1/2. Now, you have your e to the 5x over e to the 2x. When we have division, that's going to become subtraction. So this is now e to the 5x minus 2x, and that's on the top with the 1. And now you have to actually do that math. Okay, and you don't have to keep the 1 there. You can get rid of it and just write it as an e. So we'd have e on the top, 5x minus 2x is 3x, over still the 2 on the bottom from having that 1/2. So this would be your final answer. You don't want to move anything else to the top or to the bottom because we don't have any negatives going on. No, we don't have any negative exponents. Questions on those 2 types of exponent rules? Look just like the ones we had on the quiz. All right, moving on to, now this stuff, you guys, we haven't seen in a while, so pay attention to, this was a couple weeks before even Thanksgiving break. So in number 5, it just says to rewrite in exponential form. So these are the ones where we start at the little 3, the base of the log, and we just draw that arrow. You're not solving for anything. You're just rewriting this. What does log base 481 equal 4? What does that mean if you're talking about it as an exponent? Well, you follow your arrow going around. It means 3 to the 4th power is equal to 81. It's just rewriting it in an exponent. And that's it. No solving. And the same thing happens in number 6. Number 6, it's just don't let the fraction throw you off. It doesn't change anything about the pattern of what we're doing here. So we loop around, starting at the base of the log, which was 1/2. And then you have 1/2 to the -5th equals 32. And that's it. Questions about rewriting problems as exponents? All right, so let's go then to the back. And so now it's saying evaluate these
right
logs
here.
without a calculator. Okay, so
At
for
7.
the most part, it's kind of like a combo. Basically what we're saying is don't just plug this directly in.
When they went to
We
the
want to
next
know
page.
what does this mean as an exponent,
Oh, yeah, okay,
and then
well,
if
I
you
guess
need to
we'll
use
just
your
go
calculator
to-
from there, you can.
No.
All right?
Oh, yeah, it
So
is.
I would,
It's probably
for
right.
all of these, 7 through 10, you still say equals x, okay? Then you arrow around, and you'd write it as 4 to the x equals 64. This is what we'd be giving you points for on this part that's supposed to be done without a calculator, okay? You writing that out like that, that's your without a calculator part. Then you can grab your calculator, obviously, because it's already at your desk, like on the test day, and you're going to plug in different things to figure out, well, 4 to what power is 64? 4 to the 2nd, 4 to the 3rd, 4 to the 4th. What's it end up being? 3. X is equal to 3. And so that's your answer. But because these are the ones that are saying do it without a calculator, we would want to see this step right here. All right, so let's do number 9. In number 9, you still say equals x. And then you're going to loop this around. 3 to the x power, which is what we have to figure out. What will 3 to what power will give us 1? So you can test things out in your calculator, or you have to just remember this is one of our actual exponent properties. Anything to this power gives you 1. 0. So x is equal to 0. All right, let's do 8. Move this up. So equals x, loop around, write out the step. 6 to what power will give me 36? Second. So you're right. X is equal to 2. Some of them you might not even have to pick up the calculator on. Like the 8 we just did and the one prior to that where it was 0, you probably don't need your calculator. But you always have it as a backup, okay? Then the last one of this type is number 10. Set it equal to x, loop around. And it's going to look a little different than the previous 3 because now you have this big number out front, 125. To what power is now going to take us all the way back to just 5. So you have to remember, if you're going from big to small, it's going to be a fraction. But then you have to kind of think backwards, and you'd have to say, all right, well, I know my answer is a fraction, and just as a helpful hint, you guys, it's going to be 1 over some number, okay? We haven't done any where the fraction's been like 2/3 or 3/4, right? It's 1/3. In order to figure out what that bottom number is, you think backwards. You think, okay, 5 to what power gives me 125? And it's 5 to the 3rd is 125. And so I know I use this 3, and that's what's going to go on the bottom. So x is 1/3. You can always double check it in your calculator. If you're not sure on the test, you could pick up your calculator and type it in. 125 to the 1/3. Does it give me 5? Questions about those ones? All right, so now off to number 11 where we are expanding the expression. So remember with expanding, you should see the word log or ln written more than once, okay? Because that's what we're expanding it, we're making it bigger. So, and you have to kind of revisit all those rules and you're going to have to memorize them. When you see division, that expands out to what? subtraction. So this is going to be natural log of A minus natural log of B. And then that one would be done. So you don't really have work to show. You just have, that's just a one-step problem where you remember what the rule is. This was a while ago. So 13 has multiplication going on right here between the 5 and the C. This is multiplication. What does that work backwards as? Addition. When it comes to logarithms, it's addition. So this would be log 5 plus log C. You have to give the word log or ln with both parts. So that's your final answer there. All right, now 12 is kind of like 13. There's just more parts to it. So if in 13 we split up that multiplication with addition, that's the first thing we should do in number 12. So I would want to give ln to all three things going on. You have the 4, the x squared, and the y. So natural log 4 plus natural log x squared plus natural log y. But then there's one more rule you have to follow. And what is that? What do we have to do with this too? Goes out front. So then your final answer for this problem would be natural log 4 plus 2 natural log x plus natural log y. And then that one's all set. And then 14. 14 is like, did we talk about it up here? When you have a fraction, it goes to subtraction. So in number 14, we have to turn this into subtraction. And so it would start off looking like this. Log 6x squared minus log y to the 4th. From there, you then have to deal with this, and these are being multiplied right here. So we break up that multiplication with addition. This is now log 6 plus log x squared minus log y to the 4th. Then your last step is to take your exponents and put them out front, like we did on the previous problem. So the 2 out front and the 4 out front. So your final answer then in 14 is log 6, and you don't want to plug that into the calculator, leave it with the log in it, plus 2 log x minus 4 log y. Questions over 11 through 14.
All right, it's Mr. Robertson now, and what we're going to do is we're going to condense these now. So in order to condense these, we have to first look at our sign and figure out how we're going to put them together. Are we going to make it a division problem or a multiplication problem? So in this case, we have subtraction, which means we're going to make this a division problem. So this is going to become ln. We're going to take our x and put it on the top of the division problem, and on the bottom, we're just going to put our y. Looking at number 16, you can see right here we have an addition, okay? So for addition, we want to make this a multiplication problem. So we're going to combine our 5 and our z. Just write your log one time and put 5z. Whenever you have, looking at number 17, whenever you have a number out front, you need to go ahead and take it and make it an exponent to the term behind this one. So this is going to become log 9 to the second power, and we can simplify that and say 9 to the second power is 81. So log 81. Going to the top of the paper, number 18, just a little more complicated, a lot more terms here. I like to start and look at all my numbers out front. So I have a 5 that I know that is going to have to be moved back here. I have a 7 that's going to have to be moved back to the exponent of the after the x, and a 4 that's going to have to be moved back there. So this is addition. So we're going to take this and combine it to log 4, write it one time. This would be 2 to the 5th, x to the 7th, y to the 4th. Now we do want to simplify this just a little bit further. We're going to go ahead and take 2 to the 5th in our calculator. That will give us 35. So our final answer, log 2 to to the base 4, 35, x to the 7th, y to the 4th. This next one, we do have a couple big numbers. We have a 5 here that's going to have to move back, and a 3 that's going to have to be moved back to the end. This is a subtraction problem, so we need to make a division. So we'll have a log. We'll put our division sign. On the top, we're going to have x to the 5th, and everything after it we want to put on the bottom. So we'll just have a 7 on the bottom and a y to the 3rd on the bottom. Now we're going to look at solving, okay? So there's a couple different ways that we solve these when we're looking at exponential and logarithmic equations. This first type is kind of the most basic type. When we have matching bases out front, we can just cross them out. We're going to rewrite this as 2x plus 1 equal to x plus 7. Start by subtracting my x both sides. I get x plus 1 equals 7, minus 1, x equals 6 for this one. Number 21 is a little bit harder. We have to have matching bases. So what we need to do is we need to make both these 3's, okay? So when I look at 81, I think to myself, what 3 to the what power can give me 81? And we can actually take a 3 to the 4th power, and it's equivalent to 81. And then in parentheses after it, we're just going to drop this down, 3 minus x. Put our equal sign and just drop the other part down, 3, 5x minus 6. Now we can go ahead and just cross out our 3's. We will distribute this 4 into the parentheses, so we're going to get 12 minus 4x equals 5x minus 6. We'll start by adding 4x both sides. That will cross out. We'll get 12 equals 9x minus 6. Add 6 to both sides. We'll get 18 equals 9x. Move this up a bit. Divide by 9. X equals 2. All right, let's flip our paper over. Now, if we flip over to the back side, we have a couple more to do where we're going to solve. So if you look at number 22, let me zoom in on it here. Number 22, what we're going to do is we are going to have to get rid of the 9. To do that, we're going to have to use log 9 on both sides. Log 9, log 9. That will allow us to cross off that 9. Our x will just drop down. We're going to have a log 9, 35. At this point, you can type it into your calculator. Remember, when we enter this into our calculator, we want to enter it as log 35 divided by log 9. When we type this in, we get 1.618. 23 is probably one of the more difficult kind of questions that you're going to see on your test. We need to think of this as a regular equation to be able to solve this. So I see my x here. I want to move everything away from it. So the first step is just to take the 1 and add 1 to both sides. We're going to get 3e 2x power equals 27. Next step to get x by itself would be to divide by 3. We'll get e 2x equals 9. And now at this point, we have to get rid of our e, and we're going to use a natural log or ln on both sides to do that. That will cross that e out, and we'll be left with 2x equals natural log 9. And the last thing we have to do is just divide by 2. At this point, we can type this into our calculators exactly like this. ln, parenthesis, 9, close your parenthesis, divided by 2. You type that into your calculator, you get 1.098, I believe, but we'll round that up to 99. Number 24. So these are the kind that are not too bad. We just have to remember that if we have the same bases out front, we can just cross them out. So this is just going to be x plus 9 equals 7x minus 8 after we cross those out. I would start by subtracting x both sides. That gives me 9 equals 6x minus 8. Add 8 to both sides. We're going to get 17 equals 6x. Divide by 6. We'll get a decimal for this one. X equals 2.83. You could also leave it as a fraction if you wanted to. Okay, moving up to 25 at the top of the page. Very similar to the last one we did, we have log 4 on both sides, so that means that we can just cross them both out and just get 2x plus 8 equals 6x minus 12. I will minus 2x from both sides. 8 equals 4x minus 12. Add 12 to both sides. We get 20 equals 4x. Divide by 4. We should get x equals 5 for that one. All right, these last two we're going to have to undo logs. To get rid of our log 4 on number 26, what we need to do is do an exponent or a big 4 on both sides, okay? That will get rid of our log 4, and we'll have 5x minus 1 equals 4 to the third power, okay? 4 to the third power is going to give us 64, so we'll do 5x minus 1 equals 64. Add 1 to both sides. We get 5x equals 65. And then we'll just divide by 5. X is equal to 13 for that one. And very similar, if we look at number 27, you can see that we have a log base 7 here. So to get rid of the log 7, we're going to do a big 7, a big 7. That will cross out our log 7. We'll get 3x minus 2 equals 7 to the second power, which is the same as saying 3x minus 2 equals 49. Add 2 to both sides. We get 3x equals 51. Divide by 3. This one we get x equals 17.